Sono marikeliana mano. Kaile mazi zelaba. Kongle barazia lezizi mamala. Ilana kone mazazo.
Good day, ladies and gentlemen. You are welcome to another beautiful time. Today we are going to look at calculation on Young modulus. Young modulus. We look at the meaning of Young modulus last week. So this is for all the SS1 students. Physics calculation on Young modulus. I want to believe you understand what Young modulus is. Now today we continue from it and let's look at the calculation aspect. Like last week we look at the theoretical aspect of it. So today we are going to look at how to calculate on Young modulus. Now, example 1, we are told that an object weighing 0.6 Newton is hung on a spiral spring and cause it to extend by 6.0 centimeter. Now the object is removed and block of wood replacing it. Now what is the weight of the block of the wood? Now we are giving applied force F to be 0.6 Newton. Extension E is equal to 0.6 centimeter. So you have to convert to what? To meter. So divided by 10 by 100, you have what? 0.06 meter. Then now your P is what is given. That is your force 0.6. That is force constant is equal to K, which is 10 Newton. Now for E is equal to this and 0.1 meter and K is equal to 10 Newton. So weight of the wood is given as F is equal to KE. KE. You know, from K is equal to you make F the subject of formula. So we have our K to be 10 while E is given as 0.1. So when you multiply it together, you get the weight of the wood to be 1.0 Newton. Don't forget it's equal to 1.0 Newton. So the first thing you want to do here is make sure that any dimension that is not in meter, you need to convert it to meter so that everything can be on the same line. Like the extension they gave us here is 6.0 centimeter. So we need to convert it to meter by dividing by 100. Then you have what? 0.6 centimeter. Excuse me, 0.6 centimeter. So it's very simple. That is question number 1. That's the solution for it. So, and this is how to convert. This is how to do your calculation when you are asked to find the force or the weight of the wood. You know, weight and force is the same thing. So that's why I say F is equal to what? K E. F is equal to K. Okay. Now question number 2. We are given that a load of 5 Newton give an extension of 0.56 centimeter in a wire which obey Hooke's law. What is the extension caused by a load of 20 Newton? Now we have the option. That is the perfect jam question 1987. Now solution. Now applied force is given to be F is equal to what? 5 Newton, and extension is E is equal to 0.56 centimeter. So as I said, you need to convert that to what? To meter. So now force constant is equal to K is equal to F over E. F over E. Now your F is 5 Newton, then divided by what? By E, which is the extension 0.56. So when you have converted that to meter, that is 0.56. When you divide that, you are going to get 8.93 Newton centimeter. Now for F is equal to 20 Newton and K is equal to what? 8.93. Now extension, now from that will make what? E the subject of formula to be what? F over K. F over K, so that your F is going to give you 20 Newton, then divided by K that you have been able to get where you divide F over E to give you 8.93. So now extension is now F over K. F is 20 Newton while K is what? 8.93. So it's going to give you the new extension to be 2.24 centimeter. 2.24 centimeter. Now take it. We are told that a load of 5 Newton give an extension of 0.56 in a wire which obey Hooke's law. What is the extension caused by a load of 20 Newton? Now you can see that we have two load. So and they gave us the first extension So it's the second load that is causing that is using what 20 Newton that we have to find the extension, and that's why we have to find the extension here. So the first thing we need to do is to find the force constant between the first and the second. Is the constant, so is what is one that is operating in the first and the second. So when we get that, which is what 8.93, then we are able to use it for what, for the next extension. Okay, now question number 3, we are told that using the following data to determine the length L of a wire when a force of 30 Newton is applied, assuming Hooke's law is obeyed. Now we have the force applied to be 0, 5, 10 and 3. The length of the wire for, yeah, that is 500, 500.5, 501.0. Okay, now change in force applied is equal to F is equal to F minus 0, which is going to give you 5 Newton. Now change in length is E is equal to 500.5 minus 500.0, which is 0.5 millimeter. Okay, now from K is equal to KE, that is force constant. So making K the subject of formula there, we have F over what, over E. That is equal to what, 5 over 0.5, you get 10 Newton mm. Okay, now for F is equal to 30, extension E is equal to F over K, which is 30 Newton divided by 10 Newton. So we have what, 3 meter. Now to now find the length, now the length is going to be what, original length minus plus extension, rather length will be what, original length plus extension. Now original length is 500.0 mm plus extension, which is going to give us 300. So your final answer here, we are looking for L, which is going to give us 503.0 mm, 503.0 mm. So that's it. You can see from the table we are asked to find L, and they give us the what, the force that is applied that will give us that L, which is 30, So that's why we are using what, F over K, that our F here is equal to 30. We have been able to get the constant, force constant between them. Okay, now the last question here, number 4, we are told that a force of 40 Newton applied at the end of a wire of length 4 meter and diameter 2.00 mm possess the extension of what, of 0.24 meter. Calculate the stress on the wire, the strain in the wire, Young modulus of the material. Okay, now we've been able to have the understanding that when we are talking about stress, it's the force over area, which is going to give us F into what, pi r square, and the radius is given here. And for us to be able to find the radius, because diameter is given, so diameter divided by 2, so that is 2.00 divided by 2, you get 1 mm. So convert it to meter, divided by 1000 to get is 0.01 meter. Now stress is equal to what, 40 Newton, that's our force, divided by what, by pi r square, that is 3.142 times 0.0 square. That pi is represented 3.4, and what, r square that we've been able to get by the time we divide the diameter by 2. Okay, now strain is given as what, extension over original length, that is E over L. E is given at 0.24 mm and L is equal to 4 meter. So now E, you convert it to meter, I've said it before, that is 0.24 divided by 100, you get 2.4 times 10 raised to power 4 m. Now strain will now be what, that is 2.4 times 10 raised to power minus 4 divided by what, 4 is the what, is the length, that you get 6.0 times 10 raised to power 3. Now Young modulus is stress over what, over strain. You've been able to get your stress to be 12.74 times 10 raised to power there, and the strain